Hello. Good evening, everyone. Okay, welcome to our 2025 SMO Senior Round 1 going through of the questions here. Right. Firstly, thanks for stopping by. Right. I hope that you had an interesting uh, competition. Maybe not that interesting if the questions felt very difficult for you, or maybe if you felt like you could have done better. But at least now is the time where we review back and take a look at how well you think you did for the uh, SMO itself. Okay, let's take a look at question number one here. Question number one here, we are going to suppose that the roots of this quadratic equation x squared plus ax plus b are a plus b and b minus a. I want to find the value of the a minus b right here. Okay, so what we can do for this question is that we can use our Vitas theorems. So our Vitas theorem says that our sum of roots in this case will be equals to the minus a. And in this case, our two roots are a plus b as well as b minus a, right? So if I sum them up, I can get 2b. Okay, so negative a is equals to 2b. So let's keep that in mind while I take a look at the next thing to look at, which will be the product of roots. The product of roots will be what? Will be the b term. And this will be the product of a plus b and b minus a. So this is equals to b squared minus a squared. So now we have two equations involving our a and b, right? So the first one over there is basically the one that says that, okay, we want to have negative a equals to 2b. Then the second one says that I want to have b equals to b squared minus a squared. These two equations. So to solve them, what I can do is that I can take the first one and substitute into the second equation here. So I have this is equals to b squared minus what? A is negative 2b, right? So let's put it here. So actually this is going to be b squared minus 4b squared, which is equals to negative 3b squared. So this is the one that we have. Now, if b is equals to negative 3b squared, what about can b be equals to 0? If b is equals to 0, then the product of roots is 0, which means that a has to be 0 as well. That's not possible, right? Because if b equals to 0, then the product is 0, is 0, and then it means that actually a will be equals to 0 as well. Okay, so that's not possible here. So the only possibility for b will be when b equals to negative 1 over 3. That is when your b is equals to your negative 3b squared. And in that case, what will be the answer for this question? Well, you still have to calculate a, right? So a will be equals to negative 2b. So that's going to be 2 over 3. So a minus b is equals to 1. The answer, E. Okay, next question. Question number 2, we have a logarithm question. Suppose that this is equals to log 2 of m, find m. So a few things about logarithms is that we need to know some formulas. Because if you don't know formulas about logarithms, it's a bit hard to try to simplify them. First thing is this fact. 1 over log AB is equals to log BA. Now, this is a special case of your change of base. Right? So this comes from change of base. So usually when you have a change of base, you have some term else, right? Usually something of the form maybe like log A C over log A B is equals to log CB, right? But here, if you think of maybe A equals to B, then this is the one you can get, right? Within this special case here. Anyway, so this is one of them. Now, another one that you might need for this question is you can take a look at this term. You notice that the base is very big, right? So another thing about logarithms is that if you log a to the power k of base b, that's equals to 1 over k of log ab. So this is not hard to show. If you want to try to show it yourself, you can do that. Right? But let's just think about how we can use it here. So to use it, our expression here will be equals to 2025. We have this what log this thing as a base. I can bring the 2025 out. So we have 1 over 2025 times of this thing. Okay, so that's the first expression. It's just going to be log base 2 of square root 2025. What about the second expression? The second expression, remember to use this thing. So we can swap the two bases, or rather swap the two things in the logarithms, the 2 and the 2000 square root 2025. So that's just going to be 2 times of log base 2 square root 2025. So if you add one copy of it to two copies of it, turns out the answer will be 3 copies of this log base 2 square root 2025. And if I want this to be equals to log base 2 of m, what do I need to do? I need to bring the 3 back up, right? So what this tells you is that, okay, log base 2 of square root 2025 cubed is log base 2 of m. So for the answer, C. Okay, next question, number 3 here. Suppose that y is equals to this sine squared x minus 4 sine x plus 15, where x is a real number. Find the maximum possible value of y. So the idea is that we should treat this as a quadratic, right? If we let's say, another letter represents sine x, for example, we let a be equals to sine x, then our expression is of the form y equals to a squared minus 4a plus 15. And now if this is a quadratic that I want to maximize, let's try to complete the square. If you complete the square, you realize that, okay, this is a minus 2 squared minus 4 plus 15. So this is a minus 2 squared plus 11. And here, if you want to maximize this expression, we need to be careful about the range of a itself. Remember that the range of a is between -1 to 1, because sine goes from -1 to 1. So in this case, what will be the maximum of this? It will be the maximum when a is as far away from 2 as possible. So it's a maximum actually when a equals to -1. So this is as far away from 2 as possible, then the value of this expression will be equals to -3 squared plus 11. That's equals to the answer of 20. So it is B. Okay, question number 4. Find the value of this. Sine 75 degrees plus sine 15 degrees over cosine 75 degrees plus cosine 15 degrees. I know some of you, when you see this expression, you might be tempted to just substitute sine 75 degrees inside. It's tempted to substitute sine 15 degrees inside, but it is simpler than that. Notice that in the right angle triangle, we always have this following fact. If this is angle A and this is angle B, then the sine of A is equals to the cosine of B. Right. So then, in this case, what you can see is that sine of 75 degrees and cosine 15 degrees, these two are actually equal to each other. And not just this pair, in fact, the other pair, they are also going to be equal to each other. So what's this going to be? Well, it's just 1. Okay. Question number 5. Question number 5 wants you to find the maximum possible value of this 3x squared over x squared plus 2x plus 2. Now, this expression by itself is not very nice to deal with because the denominator is the term that is going to be a little bit more challenging, right, to deal with here. So what can we do to this expression? Well, if I want to make the denominator nicer, I can instead change 3x squared to the denominator. The maximum of this thing is equals to the minimum of x squared plus 2x plus 2 over 3x squared. So instead, let's try to minimize this. Now, this term right here, we can say, okay, the first one is 1 over 3, it's a constant. The second one is going to be 2x over 3x squared, that's 2 over 3x. And the last one is going to be 2 over 3x squared. We realize that, okay, we have reciprocals for this expression, right? 1 over x, 1 over x squared, this is what we have. So now it makes sense to say, maybe let's let y be equals to 1 over x. I get 1 over 3 plus 2 over 3y plus 2 over 3y squared. And then now, we know what we can do here. We can try to complete the square, right? Once again, if we complete the square, what we can get is 2 over 3 y squared plus y. So first what I'm doing here is I'm going to take out the 2 over 3, right? And then in fact, I can even put the constant term inside here, right? So that I can get something that's not uh, denominator 3. So now this term inside will be equals to y plus half squared minus 1/4 plus half. So the thing inside looks like this. And what does that mean? It means that the minimum value of this expression here is when y equals to negative half, will give you exactly 2 over 3 times of half minus 1 over 4, that's 1 over 4, which is 1 over 6. So if the minimum value of the reciprocal is equals to 1 over 6, what's the maximum value of the original expression itself? Well, it has to be 6, right? That's the answer. Okay, question number 6 here. Find the maximum value of this expression. Well, if I take a look at this expression, my first instinct is that all these numbers are divisible by 16. So let's try to take out 16 here first. And then we have 1 minus 4 sine x cosine x plus 3 sine squared x. Now we take a look at this. When I see sine x multiplied by cosine x, it feels that it should be related to something involving sine of 2x, right? But if something involving sine of 2x, how does sine squared x involve something of sine of 2x? Well, not directly, but we know that sine squared x is part of the double angle formula. Right, so here I'll use the double angle formulas of sine 2x equals to 2 sine cosine and the double angle formula of cosine 2x. Now, the double angle formula for cosine 2x, I want the one that involves sine. So in that case, I don't really want this, but I want to write it in terms of 1 minus 2 sine squared of x. So what this allows me to do is that it allows me to rewrite the expression as 1 minus, what does the 4 sine x cosine x become? Well, that's twice of sine 2x. And then our next term here, it becomes 3 times of sine squared x is actually going to be cosine. Okay, so now this expression becomes something that seems to involve only sine 2x and cosine 2x, right? And let me bring 2 from 16 so that I don't have to work with not very nice denominators. So once you bring a 2 in, this becomes a 2, this becomes a 3, the constant term becomes a 5. Then you have a minus 4 sine 2x and then a minus 3 cosine 2x. What do I do here? This is where we use the R formula. So for some of you, you may not have seen R formula yet in school, but if you know what R formula is, then R formula is basically when you have a certain trigonometric functions. So for example, you have sine x and cosine x, then you can multiply them with a sine x and then b cosine x. And then here we will have the value of it change. This thing here can be rewritten as a single trigonometric function. Normally, we write it as r sine of x plus some change of angle. Okay, so for this thing here, what we have is going to be the value of r in the R formula is square root of a squared plus b squared. So this is a well-known formula. All right. And then in that case, I can rewrite this as negative 5. Or rather, if you want, you can just write as 5. Doesn't really matter because we're taking the positive square root anyway, right? So 5 sine of x plus, or rather 2x plus some random change of angle. Do we care about what this change of angle is? No, because we know that in this case, the maximum value will be 5. So that at most, 8 times of 5 plus 5, the answer is equals to 8. Okay, now let's move on to the next question. Question number 7. Find the largest coefficient in expansion of 1 over x plus 3x squared holding the power of 8. Now, largest coefficient, some of you might think instinctively, okay, that's the biggest guy, right? That's 3x squared holding the power of 8. That one will give you the largest coefficient. Well, not really. Because if you use binomial theorem, you know that the one for uh, x squared to power of 8 will be 3 power of 8. you know the next one will be equals to 3 power 7 times 8 choose 1 times 1. You know the next one will be 8 choose 2 times 3 power 6 times 1 squared. Then you have 8 choose 3, 3 power 5 times 1 cube, and so on, right? So among all these, we need to go and compare their sizes. To compare their sizes, we just think, okay, for our combinatorial term, binomial coefficient here, is it going to be more than 8 times, sorry, more than 3 times of the previous one? So for example, from here to here, yeah, it is more than times 3, right? More than times 3. What about from 8 to the next number? 8 choose 2 is going to be 8 times 7 over 2, that's equals to 28. And you can see that, yes, once again, this is going to be more than a times 3. Now for 8 choose 3, this is going to be actually just the value of 56. So from this case, we can see it's a less than a times 3. What does that mean? It means that this one here will be the largest. And then if it's the largest, then the value here will be equals to 28 times 3 power 6. So this number is a pretty big number, right? 3 power 6 is equals to 729. Wait, 28 times 729. So here I'm just going to skip the calculation. You can try to calculate out yourself. The answer for this question is equals to 20,412, which is pretty big. Next question, question number 8. Suppose that x and y are two real numbers satisfying this equation. Find the maximum positive value of x plus y. Well, x minus y is 10, and if you take a look at this expression, there's something related to x minus y here. In fact, the first expression is x minus y squared, right? That's x squared minus 2xy plus y squared. And then the thing at the back, you can take out a y squared from both of them, and you realize there's an x minus y left over. So what this is equals to, if x minus y is 10, it's just 100 plus 10 times of y squared, 910. In other words, 10y squared is equals to 810, or y squared equals to 81. So now y has two values, either 9 or negative 9. Which is better? Well, if y equals to 9, then x is equals to 19, and y is equals to negative 9, then x is equals to 1, which is not the case that you want. So the one that is the bigger one is the first one. 19 plus 9 is 28. Okay, let's move on to the next question. Actually, I just realized my thing isn't very well balanced within the screen. Let me see if I can move it a little bit so that it looks a bit nicer when we take a look at it. Maybe something looks like this. It's a bit more centered, hopefully. Right. Okay. Anyway, next one. Question number 9. Suppose that x is a real number satisfying this equation, right? And I want to find the value of 9x squared. Now, this is something that looks scary. And then you'll see a common theme throughout this entire round 1, which is that something that looks scary oftentimes is not scary. So when I say scary with an exclamation mark, it means that not the question is just actually easier than you think. So what's happening here? Well, you have some kind of x something, then to power something is equals 96 over x minus 2 over 3. If you want to have just one real number satisfying it, then you can try to use it guess and check, because that seems to be the easier one. So you try to guess. So what will be some value that works? Well, you want to be able to guess values such that each of these is easy to calculate, right? And the reason why you want to guess something like some fraction over 3 is because they also have 9x squared here, which suggests that maybe x is something over 3. So the first thing you might want to try is something that makes this easier to calculate. What would that be? Well, if it is easier to calculate, maybe I just want to try x equals to 11 over 3. So if x is 11 over 3, what happens now? Then you will have 11 over 3 minus 5 over 3, that's equals to 2, right, to the power of 5 plus 0. So, and on the right side, you're going to be 96 over 11 over 3 minus 2 over 3. That's equals to 96 divided by 3. That's 32. So actually, both sides are equals to 32. So this is correct. Right, so suddenly your first guess is correct. Now, if you're a little bit unlucky, maybe you didn't guess x equals to 11 over 3 first. Maybe you guess x equals to maybe something like 14 over 3, right? That would be wrong. Uh, and then you'll be able to guess it on the second attempt because of the fact that the left hand side is increasing, whereas the right hand side is actually decreasing as x increases. Okay, anyway, 9x squared will be equals to uh, 11 squared divided by 9 times 9, so that's going to be 1 to 1. Okay, question number 10 here. Again, something that looks very scary. But if you commonly practice SMO past year papers, then this should be something that looks very familiar to you. In fact, if you practice enough of them, you realize that for such an expression, you just need to get a middle term. F of 0. What's f of 0? F of 0, this guy is going to be 2 to the power of 2 over 2 to the power of 0 plus 1. That's 4 over 2, that's equals to 2. And from there, you can suspect that the entire thing is just going to be 2 plus 2 plus 2 plus 2 plus 2 all the way. How come? Well, let's take a look at, for example, the first and last number. Usually you want to do pairings in this way. If you do pairings in this way, then you realize, okay, what I'm pairing here is actually f to the power minus x together with f to the power plus x. And hopefully this will be something that's nice for us. Turns out it is indeed nice because you have 2 to the power minus x plus 2 over 2 to the power minus x plus 1. And then the way we will settle the first term, okay, let me write out the second term first. The way we'll settle the first term is actually we'll multiply by 2 to the power x over 2 to the power x on both the top and the bottom. So now the expression will become the first term 2 to the power minus x times 2 to the power x, that's equals to 1. 1 times 2 to the power x, that's 2 to the power x. 2 to the power minus x times 2 to the power x times then 2 squared is just going to be 2 squared on top. So this will be the first term. And meanwhile, the second term will have the same denominator 2 to the power x plus 1, right? So if we combine them, that's 2 to the power x plus 2 plus 2 squared over 2 to the power x plus 1. And from here, you should be able to see, hey, this is just equals to 2 squared, which is 4. So every single one of these pairs from the front to the back will have a sum that is equals to the value of 4, right? No matter what x is. So how many 4s you have? Well, the way to think about it is that the average is equals to 2. So it's just 2 times of how many numbers? There are 4,051 numbers. Because you have 2025 positive, 2025 negative, and 1 in the middle. Okay, try question number 11. Oh, no, no, not try, sorry. I'm not going to go through question number 11. Sorry, I'm too used to letting my students try questions. Sorry, now I'm going to go through question number 11. Let n be the value of this expression. For theta between 0 and pi over 4, find the value of m squared. So what's the trick? Well, the trick is that if you observe this expression, you get a little bit suspicious of the cosine theta holding the power 4, right? Because everything else is in terms of double angle, but then this guy is single angle. And then we can try to think, okay, is there any way to convert double angle formula? Well, here, if you want, then there's one that relates cosine 2 theta with cosine squared. So let's use this thing. And we notice that I can write it as 1 plus cosine 2 theta is this guy, right? So if I square it, I can get my 4 cosine to the power 4 theta. So therefore, the expression is 14 minus sine squared 2 theta minus away the 1 plus cosine 2 theta squared. And if you simplify the numerator, you have 14 minus sine squared of 2 theta minus 1 minus 2 cosine 2 theta and then minus cosine squared of 2 theta. So hopefully, when you take a look at this numerator, you are able to notice that in fact, the minus sine squared of 2 theta together with the minus cosine squared of 2 theta, they add up to give you minus 1. So actually, when you simplify it, the numerator is 14 minus 1, so 12 minus 2 cosine 2 theta over sine theta. Okay, question. How do we continue at this step? Actually, the way to continue to do this is that I don't like to use too much trigonometry, so I decided to use algebra at this step. Because I noticed there's a relationship between sine 2 theta and cosine 2 theta, right? If theta is between the values of 0 to pi over 4, then we can see that the value of sine 2 theta is going to firstly be positive, and cosine 2 theta will also be positive because they are both in the first quadrant, right? And if they're both in the first quadrant, then what we can do is that we can just try to set algebra to do that. So what I'm going to do is I'm going to set x to be sine 2 theta. So the thing that I want to minimize is going to be the term uh, 12 minus something over x, right? What's cosine 2 theta? Cosine 2 theta is going to be 1 minus x squared, then you take the square root, okay? Because it's positive. So to minimize this thing, what we can do is that we can let this be equals to k and we try to solve for the boundaries of k. So we're treating this as a quadratic equation because when we multiply the 2 over, when we multiply the x over, I can set up as minus 2 square root of 1 minus x squared equals to kx minus 12. And then now I have a quadratic equation. So this will give me 4 times of 1 minus x squared equals to k squared x squared minus 24 kx plus 144. Move everything over. 0 equals to k squared plus 4 of x squared, still minus 24 kx, and then 144 minus 4 becomes 140. So in that case, if there is a solution for x in this quadratic, it means that the discriminant must be bigger than 0, right? So discriminant here will be equals to, let's figure out, b squared minus 4ac. So that's going to be 24k squared minus 4k squared plus 4 times 140. Okay, so 24 squared is 576. And then 4 times 140 is in fact equals to 560. Then you have a minus 16 times 140. Let's leave it like that first. Then we have 16k squared minus 16 times 140, right? Yeah, this is what it looks like. So for the discriminant to be bigger than or equal to 0, we just realized, oh, k squared has to be at least 140. And then we are done, because in this case, actually k is the minimum value we're looking at. So probably I should have just set it to be equals to the letter m, but I didn't realize it. So actually, here we have already found the minimum value, 140. Okay, question number 12. We have let gx be equals to x cubed plus 3x squared minus x minus 5, and suppose that we have 3 distinct variables of gx, and then we'll find this thing here. Now, I was almost tricked by the expression in this question here, because actually, this question, the way they check it in the actual SMO is a bit weird. So I'm not sure whether I should follow the actual one SMO or the one that I have over here. So only difference is that the middle one is going to be the floor function of the absolute value of alpha 2. But I believe that probably the SMO itself made a mistake, because as we saw in the later questions, there will be some mistakes made as well. Okay, so anyway, it doesn't really matter which version we do it. You'll see why soon. Because the way to do this question is to use estimation. When we use estimation, we want to estimate the roots of this x cubed plus 3x squared minus x minus 5. So what do? We first figure out in between which real numbers on a number line it will be equals to. The value of x at 0, what is it going to be? It's going to be negative 5. So it's going to be somewhere here, negative 5. When x is equals to 1, where is it going to be? Okay, let me move negative 5 a bit closer in case I need more space later. Okay. When x equals to 1, it's going to be 1 plus 4 minus 1, 1 plus 3 minus 1 minus 5 is only going to be negative 2. Right? So it's right here. When x equals to 2, you can see that it's definitely bigger, higher than the x-axis, right? So I don't know exactly what value it is, but it's going to be bigger. So we know that there will be one solution between 1 and 2, right? Okay, would there be anything else between 2 and infinity? Our answer is no, because it will keep increasing from that point onwards. Let's calculate the value at negative 1. At negative 1, it is minus 1, minus 3, plus 1, minus 5. Wait, no, sorry, minus 1, plus 3, plus 1, minus 5. So actually, it's going to be negative 2 as well. Yeah, sorry about that. And then what about the value of x at negative 2? Well, if you try the value of x at negative 2, you realize that you get, this is a minus 8. And let me write it down, because I need to write it down. See, minus 8 plus 12 minus negative 2, that's plus 2 minus 5. So that's going to be 14 minus 13. That's going to be equals to 1. So it's going to be above. And then because you know how cubic graph looks like, you know that at this point onwards, you're going to continue to go negative further and further, right? So know that, okay, at this point, you'll go negative further and further. Oh, wait, there's one thing I forgot to check. I forgot to check the value at negative 3, but I think that one is pretty easy to check because it's minus 27 plus 12 minus plus 3 minus 5, right? It's going to be very negative. This is a negative 17. So it's already down here. Okay, of course, it's not a straight line. So it looks something like that. Okay, so now you know one of the roots is going to be, okay, wait, yeah, it does matter. Yeah, it does matter the orientation in which you write the symbol actually. Okay, so the smallest root is going to be between negative 3 and negative 2. So when you round down and take the absolute value, it's going to be negative 3, and then you take absolute value is 3. The second one is between negative 2 and negative 1. Depending on what you do, you can get different answers. If you round down first, then you take absolute value, it looks like this. However, if you follow the one in the official booklet, the symbol that I wrote is the one up there, up here. So then the one you should do is actually take absolute value first to get something that is negative 1 point something, right? So it's between uh 1 and 2, and then you take the absolute value of it. Sorry, you take the floor function of it, that's going to be equals to 1. Right, so it does have different values. And finally, the last one here will be um you round down the value between 1 and 2, that's going to be 1. The absolute value of that is just going to be 1. So if it's the bottom case, which more likely it is, because unless they admit they make a typo, then it's going to be 3 plus 1 plus 1 equals to 5. Right, so if they indeed made a typo, then it will be 3 plus 2 plus 1, which is 6. Okay, question number 13. Question number 13 is one of those questions where if you took the examination itself, you know that they did make a typo on this question. Indeed, because this thing here was missing, right, during the competition itself, and also the fact that n equals to 2025 was missing. Now, question number 13, what does this look like to you? It looks like a big, scary looking question, right? Scary. Extremely scary. So scary that probably anyone who takes this competition will probably decide not to take SMO again because they have never seen this kind of humongous monsters staring right at them. But as I mentioned before, the scarier that it looks, the not so scary it's supposed to be, right? It's supposed to be easier to be done. But how? The way to do this question is that we need to understand what it actually means. What it actually means is a combinatorial problem. It's a combinatorial problem where you can think of each one of these n minus k1, k1 minus k2 as gaps. So if you take a look at the boundary, you're summing from uh 0 to 2025. Okay, so 2025 is bigger than or equals to k1. But then if you look at k2, wait, what? Oh, they wrote this wrongly actually. Oops. This is supposed to be k1. This is supposed to be k2. This is supposed to be k of 2097. They wrote this part wrongly, yeah? Sorry about that. If you look at the second term, it's summing from K2 to K1. So if it's summing from K2 to K1, then actually you know, okay, K2 is supposed to be less than or equals K1, right? K3 is supposed to be less than or equals K2, until K2098 is supposed to be less than or equals K2097. And then K2098 is going to be at least 0, right? Because we start counting from a case where it is 0 until I hit some number. So this is what it looks like. Now, with that, we can understand a little bit better what happens when n is 2025. This is the gap in between the first pair. This is the gap in between the second pair. Or this is the gap in between this pair, and then this is the gap in between K209 and 0. So each of these are the gaps. So if each of these represents the gaps, then what we can do to this question is that we can actually use new variables. Let's call this gap A1. Let's call this gap A2, this gap A3, and so on. This gap will be A of 2098 because these two numbers must match. And then the last gap will be A of 2099. So first thing we notice is that the gaps A1, A2, A3 until A 2099 adds up to 2025. Right, so in fact, some of these gaps will be exactly zero, but we don't really care. So this is what it looks like. And then next, what do you notice? You notice that the condition that I wrote in red color just becomes the condition that actually A1 dot 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 A of 2099 is all at least zero, right? Now, what happens during the summation? What happens during the summation is that basically now you're summing over all possible pairs. Because this one here, you are summing across all possible values of A1. This one here, you're summing across all possible values of A2. This one here, you're summing over all possible values of A3. This one here, you're summing over all possible values of A2009. So therefore, n itself is the sum of all combinations of A1 dot, 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 A2029, sorry, 2099, satisfying right, their sum is 2025. Okay. In English language, this is what this symbol means. Sum of all combinations of these 2099 tuples of numbers satisfying their sum being 2025. And then now what's happening at the back is n factorial over a1 factorial, a2 factorial, dot, 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 a 2099 factorial. Where have we seen this before? We have seen this as a number of ways to arrange stuff in a row with repetitions, right? So this is equals to the number of ways to arrange uh, maybe A1 of something. So let me call it something. Let me give something a name. A1 of maybe if you want funny shape, let's do A1 of star. Right. Then you want to do A2 of maybe some other shape, A2 of maybe triangle, all right, up to you, whichever one you want to choose. Dot, 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 until A2099 of some random shape again. I don't know what you want at this point. Maybe circle, something like that. Right. So number of ways to arrange all these shapes in a row. Okay. With repetitions, of course. That's why we have to divide by all these factorial, right? But if you think about it, is there any other way we can interpret this? To interpret this n as the sum of all combinations of this guy satisfying their sum is 2025 and the number of ways to arrange it in a row. Basically, in other words, n is, you can think of it as da, 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 this thing here. You have 2025 gaps, right? Each thing can be up to 2029 objects. So you have 2099 objects inside this range. No space, so I'm going to create a new one on the next page so that we can do it together. What does it mean? So let me create a new one. So just now we figured that okay, n is the number of ways to do this. So how many ways is that? Well, if each gap there is 2099, or each position there's 2099 possibilities, the number of ways to do so, it will be equals to 2099 to the power of 2025. Whew. Okay, finally we have a numerical value for this big N. So now that we have numerical value of big N, we're not done yet. We have to go calculate the remainder when this big N is divided by 3000. So how to do? Well, I noticed that 2099 is very close to a multiple of 100. So probably the idea for this is to write it as this number minus 1 and use your binomial theorem, right? After all, 2025 is a multiple of 25. That's pretty useful. So if we use your binomial theorem, this will be congruent to negative 1 to the power of 2025 as the first term. The next term will have one copy of 2100. Then you have 2025, choose 1 times this thing. And then the next one you have, oh, sorry, I forgot negative 1 about 2024. Then next one you have 2025, choose 2 of 2100 squared, negative 1 about 2023, and so on, right? Every single other number will be divisible by 3000. In fact, already this number is divisible by 3000 because this number here is um okay, 21 is divisible by 3, and then you have a 100 squared which is divisible by 1000. So everything else you don't have to consider. So you only need to consider the first two guys, which are going to be negative 1, and then you have a 2025 times 2100. Now, is this a multiple of 3000? So, um, is it? Wait, let me just calculate. I don't think it is. Yeah, I don't think it's divisible by 3000. You'll leave some kind of remainder, but I'm not exactly sure what it is. Okay, so let's do a quick calculation here. So, 21 times 25. No, sorry, 2025 times 21. 2025, 4050. So this part here is going to be 405000. Wait, what? Isn't that? No, wait, no, I did the assumption wrongly. Wait, sorry about that. Let me fix this. Let me fix this. I forgot the even at 25544. Okay, this is what it looks like. So it should be not this, but 4252500. Yeah, okay, very nice. Okay, so if I want to divide this thing by 3000, what do I get? Well, 42 is a multiple of 3, 51 is a multiple of 3, so this is congruent to minus 1 plus 1500. So that's going to be 1499. For question number 14, we have a bias 5-sided dice that faces labeled 1, 2, 3, 4, 5, and probability P of coming up as an even number. Then you realize that, hey, wait a minute, then there's no need for you to say the faces are labeled 1, 2, 3, or 5, right? Because if we did it, if they is already biased, then there's no need to tell us what the faces are. Given that the probability that 3 tosses result in an odd number in 6 independent tosses of these die is 8 over 225, and the probability and the possible values of P are P1 and P2, find the value of 1 over P1 times P2. So for this question, all right, this is basically if you have an even, then it is P. If you have an odd, then it's 1 minus P. So the chance that it will be 3 odd, 3 even in 6 tosses will be 6 choose 3, the number of ways to arrange your results, times P cubed times 1 minus P cubed. This is 8 over 225. 6 choose 3 is 20. Then you have a P times 1 minus P cubed, which is equals to 8 over 225. So let's try to divide by 20. Yeah? P times 1 minus P cubed is equals to, what is that going to be? That's going to be 88 over 225 divided by 20. So 8 divided by 4 is going to be 2. 225 times another 5, that's going to be 1125 and 1125. So this is your value. Okay. So what does that mean? It means that you can try to take the cube root of this. Now, is the cube root of this easy to take? Well, to do that, we actually need to factorize your 1125, right? So maybe it was not the right idea to multiply it in. Maybe I should have just kept it as 225 times 5, which is 15 squared times 5. That's equals to 5 cubed times 3 squared. So if I take the cube root here, P times 1 minus P will be equals to, if I take the cube root here, there's a cube root of 2 on top, there's a 5, and then there's a cube root of 9 below, right? Because from the 3 squared. Okay, so this is what it looks like. Okay, so your two possible values of P, they satisfy minus P squared plus P equals to this guy. right? This guy. In other words, p squared minus p plus this guy. So now we know that, okay, if this is our quadratic equation using Vita's theorem, we know that our product of P1 and P2 should be equals to just this term over here. Okay, so the final answer for this question is 1 over P1, P2, then round down. That's going to be 5 times the cube root of 9 divided by the cube root of 2 and round down. So if I want to do that, I need to figure out roughly how big this is, right? And to do that, maybe what we need to do is to bring the bring the 5 in back in the cube root. So maybe it was not a good idea to simplify cube root of 1225 anyways, right? Because what we need to do here is cube root of 1225 over 2. Right. Anyways, so this is around cube root of 560 something, right? Something like that. And if you round down, that will be goes to 8. Okay. Next question. Question number 15. I dislike this question quite a lot because this question feels too much like a school math question and also it's quite tedious. Let C1 be the curve y equals to x squared. Then you're supposed to rotate C1 anti-clockwise 75 degrees. So new y equals x squared looks like something that has uh, this as a line of symmetry. Right? So this is your new C2. And C2 can be written in this form. Find the value of this 8 minus 4 squared 3 plus, or the absolute value of the sum of coefficients. Okay, how do I do this? Well, is there any way we can convert the terms, the points from C1 to C2, or let's say from C2 to C1? Well, there is such a way. Right? So there's this thing called a rotational matrix that you can multiply by. So if any of you know matrices, in fact, you might have heard of that before. But if you didn't hear of it, never mind, we can try to derive it on the spot. Basically, what it means is that if you're given a point on some kind of, let's say, xy plane, we can let it have some kind of polar coordinate because I want to do rotation. So if I want to do rotation, if I have some kind of polar coordinate, this will be some r cosine theta, r sine theta. And then when you want to shift it back by 75 degrees, so maybe something like here, then what you want to do is to replace the angle. How to replace? Well, if the angle turns back by 75 degrees, then it makes sense. Then what we are doing here is just we are replacing by uh, r cosine of theta minus 75, r sine of theta minus 75 degrees. Right? So for this, what we need to know is that we need to know our values of expanding using a cosine and sine formula for the angles. Now, to do that, what we can do is that we can write out formula. Right? Cosine of theta minus 75 degrees, what's that? That's going to be cosine theta, cosine 75 degrees, plus sine theta, sine 75 degrees, right? You see, it's quite boring. Then the next one here, sine of theta minus 75 degrees is going to be sine theta cosine 75 degrees minus cosine theta sine 75 degrees. Hopefully I didn't make a mistake. So these are your new equations. Right. Now if you multiply them by r, which I'm going to do, so then you can see that, okay, the new points are going to be uh, x times cosine 75 degrees plus y times sine 75 degrees. This is for your new x, so let's call it x prime. Your new y will be equals to y times cosine 75 degrees minus, wait, sorry, y cosine 75 degrees minus x sine 75 degrees. Yeah, that looks correct. Okay, so it looks pretty ugly. But now, how to convert y equals x squared into your new equation? Does your new equation satisfy y prime equals to x prime squared? Yes or no? Answer is no, right? Because the new curve is not the curve y equals x squared anymore. It is the old curve that still satisfies this. So what we do now is that we need to express our x and y in terms of our new curve x prime and y prime. And then that will tell you what the thing satisfies. Okay, so this is the part where it's quite tedious. How to express x in terms of x and y in terms of x prime and y prime. Notice that you can, for example, multiply the first one by sine of 75 degrees. Wait, no, sorry. Multiply the first one by maybe cosine of 75 degrees, multiply the second one by sine of 75 degrees, and then subtract them. So then now you can figure out from here, x is supposed to be x prime cosine of 75 degrees minus y prime of sine 75 degrees, I think. Uh, yeah, that's right. Or then the other case to figure out y prime will be you take the first one, you multiply by sine of 75 degrees, you take the second one, you multiply by sine of cosine of 75 degrees, and then you subtract them. No. Wait, what? No, sorry, you add them. Yeah, you add them. So now what you have is, wait, yeah, you add them. You add them, you can get y is equals to x prime sine of 75 degrees plus y prime sine of 75 degrees or something like that. Wait, y prime cosine of 75 degrees. So basically now you have your original equation in terms of your original coordinates x and y in terms of x prime and y prime, your new coordinates. Okay, sure. One last step. Use the fact that the original equation is y equals to x squared. So we need to uh, write down y is equals to x squared. Oh no. Yeah, so this is our new equation C2. So how to simplify? Well, unfortunately, we need to know the values of cosine 75 degrees and sine 75 degrees here, which are not too hard to do if you remember the one for the triangle. If not, you can derive it on your spot. 15, 75, 90 degrees triangle, the ratios are 1 to square root 6 minus square root 2 over 4, square root 6 plus square root 2 over 4. This is well known. So sine 75 degrees is the plus. Right? Square root 6 plus square root 2 over 4. Cosine is the one with the minus. So it looks something like this. Okay, wait up. I'm a little bit staring at too much math right now. So it's x prime of this square root 6 plus square root 2 over 4 plus y prime of this square root 6 minus square root 2 over 4 equals to uh cosine 75 degrees square root 6 minus square root 2 over 4 x prime. Uh, then the other guy is, wait up. Sine 75 degrees. Sorry, I cannot think right now. Is the square root 6 plus square root 2 over 4 times y prime. Okay, so this is what we get. Okay, again, I'm going to shift it onto a new page because there's not enough space for me to finish writing this. Okay, so this is our new equation. Let's expand out and see what we can get. Right, there's an 8 minus 4 square root 3 here. Hopefully, when you do this square, you do get 8 minus 4 square root 3. Huh? If not, there's going to be too much more work for you to do. So let's try the first term first, as this one. What's that going to be? This guy squared. That definitely doesn't look like an 8 minus 4 square root 3 to me. But anyway, oh, okay, the numerator is 8 minus 4 square root 3. Yeah, when you square it. Okay, the numerator is 8 minus 4 square root 3. That's nice, because later on you just need to multiply by 16, right? So actually, if you notice the numerator is 8 minus 4 square root 3, instead, why not just multiply by 16 straight away before you even square it, right? So actually, I'm going to multiply here by 16 before I attempt to square it. I multiply by 16 first, and then I square, then you should get this term, square root 6 minus square root 2 squared, which is 8 minus 4 square root 3 of x prime squared. How do you even write x prime squared? X prime squared. Yeah. Then the one for y prime will be basically the same thing, 8 plus 4 square root 3 of y prime squared. Then the xy term is going to be minus 2 square root 6 minus square root 2 square root 6 plus square root 2 of x prime y prime. If you simplify it, this is going to be 2 times 4, that's 8. minus 8. And then on the other side, when you multiply by 16, you can get 4 square root 6 plus square root 2 of x prime, and then 4 square root 6 minus square root 2 of y prime. Something like that. Oh, wait. Something like this, basically. Okay. Phew. We finally have everything. This is what you think the thing looks like. So therefore, the value they're looking for will be rounding down of this 8 minus 4 square root of 3. Your b term here will be your 8 plus 4 square root of 3, so they cancel each other out. Then c is negative 8. C is negative 8, so when you take the absolute value, it will be equals to 8. Then d and e, when you bring them over and take the absolute value, will be 4 square root of 6 plus square root of 2, 4 square root of 6 minus square root of 2. I think so. Hopefully I didn't make a mistake here. So that's a 24 plus 8 square root of 6. Yuck. What's this? How to estimate 8 square root of 6? Is it possible to do directly? Not really, right? It's 8 times 2.6 or something like that. It's probably safer to just calculate the thing underneath the square root, which is square root 64 times 6. That's square root 384. This is going to be between 19 and 20, I think. Right, yeah, it's between 19 and 20. So it's going to be 43 when you round down. Okay, we're finally done with this question. Oh, that took way longer than I wanted to. Okay, next question. Question number 16. We have scary looking question. And scary looking question means I'm happy. Because it means I'm happy means because probably there's some kind of nice trick to make this really fast. I just have to spot what this nice trick is. For logarithms, there's something that you need to know as a formula for such questions, which is this fact. Log AB times log CD is equals to log AD times log CB. So what this actually means is that if you have two logs with different bases, you can actually swap the terms on the inside to get to D and B. Now, if you want to try to prove it yourself, you can try to do it. I will not show you how you can prove it here. But what does that mean? It means that you can swap the 2025 and the 2. So they have log 2, 2, which is 1, right? Then after that, you can swap the 2025 and the 3. You can get log 3, 3, which is 1, right? So in some sense, what you're doing here is you're pushing the 2 to the left, you're pushing the 3 to the left, you're pushing all the way the 99 to the 98 to the left, and 99 to the left, and you're pushing the 2025 all the way to the back. So AMN is going to be 1 over log 2, 2, log 3, 3, log 99, 99, right? And then finally, you have this log 2025 to the power of mn 2025. Now, using the idea that we saw back in question number 2, what is this term going to be? This term is going to be 1 over mn of log 2025, 2025, right? So it's just 1 over mn. So actually, from here, we can figure out that AMN is just 1 over 1 over mn. That's equals to mn. Okay. So SK is going to be what? SK is going to be the sum of all these things, which will be 2025 times 2 plus only 2025 times k. This will be equals to 2025 of, wait, why does it not start from 1? I just realized. Because, okay, I mean, we can do it. So, but I'll prefer if it started from 1, right? That would be nicer to add. Okay, anyway, there are k minus 1 values here. The average is k plus 2 over 2. So this is what it looks like. Yeah. Okay, never mind. I take back my words that I like scary looking questions. I don't like this question now. So this is what we have. And then now, basically, what's 1 over sk then? This is going to be 2 over 2025 times 1 over k plus 2, k plus 1, right? I think so. Yeah. Okay. So t will be 2 over 2025 of 1 over 1 times, because k equals to 1 here, the first one is 1 times, no, k equals 2. First one is 1 times 4, the second one is 2 times 5, 3 times 6, 4 times 7, dot, 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 right? So this will be 2 over 2025 times a further 1 over 3 of 1 over 1 minus 1 over 4 plus 1 over 2 minus 1 over 5 plus 1 over 3 minus 1 over 6 plus 1 over 4 minus 1 over 7, dot, 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 dot. So in the end, when you cancel out, minus 1 over 4 plus 1 over 4 minus 1 over 5 plus 1 over 5 and so on, only uh, the first three terms here will be left over. So this is 2 over 2025 times 3 of 1 over 1 plus 1 over 2 plus 1 over 3 is 13 over 12. Wait, no. It is 11 over 6. Oh, what's this? That's disgusting. So anyway, 1 over t will be equals to 2025 times 3 squared over 11. And then you have to round up. Okay. Here, I'll just keep the calculation. 2025 times 9, that's equals to 18225. Then you divide by 11 here, you get roughly 16.56 point something. So it's 1657 when you round here. Okay, I'm starting to dislike all these scary looking questions. I thought scary looking questions were nice, but nope, they were scary after all. Okay, next question. Question number 17. We have these two lines and x-axis tangent the circle R. This is one of those questions that is poorly phrased because at first I thought it was some other circle. At first I was thinking to myself, okay, this because I like to think in the first quadrant. So to me, this was my x-axis, this was my y-axis, this was my one of the lines, this is my other line. I was thinking to myself, the circle should look like this actually. And I thought to myself, the circle look like this, we should make the answer non-integer because this will be 40 over 3 and this will be the radius. So I was very confused why the answer was not integer. But now, after I move out of my view from the first quadrant, I understand what the question means now. What the question actually want to mean is these lines are in the entire xy plane. So let me draw it out for you. Okay, again, your 40 over 3 mark will be right here. When the y values, when when you have the y values equals to 0, the x-intercepts will be at 10 and minus 10. So somewhere here and somewhere minus here. So actually the lines, they look like this. Oh, that's not a good drawing. This and this. Again, that's not a good drawing. And then, of course, the x-axis itself. Which brings me to an important question. They probably mean the circle in between, right? But it could also have been this thing, it could also have been this thing, it could also have been this thing here. They could also have been these three circles, which are tangent, right? All the x circles. So they didn't phrase it very well. But anyway, probably they mean the internal circle. So let's try to draw that. Okay. Now the question is how to do. Well, if you take a look at this diagram here, then you notice that firstly it is symmetric. It reaches to the bottom at some specific value here. It touches the point of tangency somewhere here. And then usually that means that you want to draw out from the center of the circle to the point of tangency here as well. This will be the same. So if this is 10, then this is 10 as well. Because they are both tangents to the circle. Okay, so then what do you see? Actually, this triangle is a 3, 4, 5 triangle. You can see that because of the fact that this to this is 3 to 4. Right, so it's a 3, 4, 5 triangle, which means that if I call this value as r and this as r, then this length here will be 5 over 3 times 10 minus 10, which is 20 over 3. This length here will be 40 over 3 minus r. So then you have a right angle triangle that looks like this. R, uh, 20 over 3 and then 40 over 3 minus r. You can use Pythagoras theorem to do, definitely. But actually, you should also use similar triangles because of the fact that the angle at the top is the same as angle for the 3, 4, 5 triangle. So actually, we see that this triangle must also be 3, 4, 5. Right? So instead of using Pythagoras theorem, why not let's just use the fact that it's 3, 4, 5. Then if this is 20 over 3, how do I find the value of r? I can take this multiply by 3 over 4. So that's 5. So r is 5. Okay, um if you solve by Pythagoras, you also can also get r equals to 5. Okay, question number 18 here, we have our epsilon, our universal set is this 1, 2, 3, 4, 5, 6, 7. Then they tell you this A intersect B intersect C, all this kind of nonsense, and that immediately suggests that you should draw a Venn diagram. Okay, so let's draw a Venn diagram here. The first circle, the second circle, and the third circle. The first condition says that A intersect C is empty. Okay, so intersect C is empty. So there's not going to be anything inside here. Let me shade this region to make sure that I don't put anything within here. Huh? Now, A intersect B union B intersect C is 1, 2, 3, 4. Where is A intersect B union B intersect C? A intersect B is here. B intersect C is here. So the union is 1, 2, 3, 4. So okay, these two green union is 1, 2, 3, 4. So you are going to split 1, 2, 3, 4 across these two categories. What is S1? A prime intersect B prime intersect C prime is this one, where it's outside of all ABC. Whereas S2, A intersect B prime. Those are the values in A that's not in B. In A that's not in B is here. S3 is in C but not in D. That's here. And S4 is in B but not in A and C. That's here. So realize that actually the entire shape has been cut into the region that is nothing, which is red color, and then the two green regions, and then the four purple regions, S1, S2, S3, and S4. So what you realize is that the 1, 2, 3, 4 has two choices of where it can go, right? The left green region or the right green region. Meanwhile, 5, 6, 7 has four choices. It can go in S1, S2, S3, or S4. So the answer is 2 times 2 times 2 times 2, 4 times 4 times 4. And this thing here looks like a 2 power 10, right? Is that true? Yeah, 1024. Okay, question number 19. Finally, a not so boring question, an interesting question. In the diagram below, we have a smaller circle with center O on the circumference of a bigger circle. So with that, it tells us maybe I want to draw all the all these things. It's a bit hard to see. Can I make it? Hmm. Actually, you know what? I'm gonna uh reproduce the diagram but bigger. So watch this. Boom. Yeah. Okay. We don't need the remaining part of the diagram, right? Because of the fact that the circle doesn't do much for us. Anyway, yeah. So now I can draw my radius in piece. Very nice. Like that, like that. Yeah. So what I can tell is okay, if angle PRS is 20 degrees, then we also have another 20 degrees right here. And from the fact that this is a tangent to the circle, to the big circle here, what does it tell you? It tells you this 20 degrees can also go right here. Right, so we have another 20 degrees. But it doesn't stop there. It doesn't stop there. Because of the big circle, the 20 degrees can also go here. And because of the fact that OQ is equals to OP, the 20 degrees can also go here. So it's a 20 degrees madness festival, right? Okay, now, the question that they want us to find is this angle STQ, how to find? Actually, we're already done. Because our big triangle, PSR, I already labeled all the angles beside the one in red color. I have 4 copies of 20 degrees in this diagram already. So then the one in red color will automatically be the last angle here. So this angle will be equals to 180 degrees, minus 20, minus 20, minus 20, and minus 20, 100. Okay, question number 20. Okay, another scary looking question, but I promise, this one is nice. Um, okay, maybe not that nice. Okay, nice only if you've seen it before. This is called the Vandermont's identity. Vandermonde, Vandermont, I have no idea. Vandermonde's, maybe. Okay, Vandermonde's identity. So what his identity says is actually a more general case of this. His identity says this thing. He says that, okay, if you're taking, wait, I don't remember. Wait, let me try to recall the identity. Uh, they are saying that m plus n choose r is equals to, oh, I cannot remember this term. Basically, the summation of m choose 0, n choose r, m choose 1, n choose r minus 1, dot, 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 all the way until m choose r and n choose 0. This should make sense to you, right? Because if you think about it, you can say, okay, let's say I have, um, okay, let me think. Okay, let's say I have m pens, and let's say I have n shorts. How do I choose my the thing that goes on my legs when I go out today, right? So the idea is that okay, I can choose none of the wait, I don't want to choose R pen things to wear on when I go out. Wait, that's not a good example. But basically you can think of it like this. Okay, maybe I have let's say like M apples and N bananas. And then I want to choose R fruits. Okay, that's a more valid example. Okay, that's a more valid example. If you have M apples and N bananas, then I want to choose R fruits. Then how many ways you do that? I can say that I want 0 apples, and then I want all R of bananas. That will be this way, right? I can have 1 apple and then R minus 1 of bananas. That's this way, and so on, all the way until R apples and 0 bananas, right? Okay, so these are the ways I can have. Okay, so it makes sense combinatorially that this is true. Now for this question, what they do is that they choose m equals to n. Okay, so then it looks like 2m choose r is something else. But not only that, they choose m equals n equals to r. So actually it's 2m choose m. Then I'm thinking, what? M choose 0, n choose m choose 1, m choose m minus 1, and dot dot dot. But then if you think about what that actually means, because recall the idea that m choose r is the same as m choose n minus r, you can flip the numbers here, 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 and here. So we can rewrite them. So the first one, you can still write it as m choose 0, but the second one, you choose to write it as m choose n minus m. That's 0 again. Then this guy, you have a n choose 1, but then you can flip the second one and write down m choose 1 again. All the way until the last expression here where you have m choose m, and then you flip the last guy, that's going to be m choose m again. So this is exactly what the question is doing. So from here, actually, we can tell that A is equals to 4050 choose 2025, and B is going to be 4048 choose 2024. There, this. Okay, and then we're going to divide A by B. So A, if you notice, this is 4050 factorial over 2025 factorial times 2025 factorial divided by 4048 factorial divided by 2024 factorial 2024 factorial. So simplify. That's 4050 times 4049 when you cancel out the big factorials. Then you're dividing by 2025 when you cancel out the small factorials. So this is what it looks like. Now it's pretty easy to see that this is a little bit less than 4, right? A little bit less than 4. Because the first fraction is exactly 2, the second fraction is a little bit less than 2. right? So it's a little bit less than 4. The answer for this will be equals to 3. Okay, and now for the final 5 questions. The final 5 questions are the weirdest 5 questions I've ever seen in the SMO Senior Round 1. Starting off with this question, which is blatantly easy. This is a primary school math and question, right? When I see this question, I was shocked. They say that you have a rectangle here, the area of triangle APB, and then the triangle DPC add up to 2025. Obviously, the area of the other two will also add up to 2025 because the shaded is half of the rectangle. So that's it. The other half is also 2025. So I don't know what this question is doing here. But when I see question number 22, I'm shocked again. I think this is the first occurrence of differentiation in the SMO senior. At least I think so. I'm not exactly sure. I'm very shocked that differentiation appeared. And they use this notation which maybe not everyone realize they are doing differentiation. Right? People might be confused at what this f prime mean. But anyway, what you want to do is that they want to differentiate this guy first, differentiate your fx, then put in x equals to 27, then put in x equals to 2027. So how to differentiate fx? Notice that there's one guy that's a bit special. Because this value, when you put in 2027, the value is 0. So what we can do is that we can use product rule on fx. How to use product rule again? If you remember, if you differentiate, okay, maybe some of you don't even learn this before, but if you differentiate two functions, let's say f and g, then it is f prime g plus g prime f. In other words, I'm going to call the first part of this g. I'm going to call the second part of this. Wait, no. Okay, let's call it g and h, basically. So if you differentiate this fx here, it's going to be g prime h plus h prime g. G prime is not something that's easily findable, right? Because you take x minus 1 times x minus 2 times, sorry, x minus 2026, you differentiate it. Luckily, you don't need to calculate because h is x minus 2027. So when you put in x equals to 2027, this will disappear. Then the other guy is h prime g. H prime, if you differentiate h, is easy, it's just 1. And then g itself will just be x minus 1, x minus 2, da 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 da, x minus 2026. So now, when x equals to 2027, the first part is 0, the second part is what? The second part is 2026 factorial. So now you want to figure out the value of 2026 factorial when divided by 2027 factorial. Sorry, when divided by 2027. What's the remainder? Now here, I really pray that 2027 is a prime because I want to use Wilson's theorem where they say that p minus 1 factorial is congruent to negative 1 mod p. So if 2027 here is a prime number, then I'll be very safe to put down just negative 1 or 2026 as the answer for this question. So if I'm doing this during competition, which you are, I'll just put down this answer and move on. But because I'm going through this question, let's actually check that 2027 is not a prime. How to check 2027 is not a prime? You check for check for 2 is easy. Check for 3, 7, 11, 13, 17, 23, 29, 31, 37, 43, right? And the next prime number, 47 is too big. So you only need to check 5, right? Only, as they say. Wait, I forgot 19. Yeah, so you after you check all those, then you realize that it's a prime. And then, oh wait, there's even 41. I even forgot about 41. Oops, my bad. So you have to check 10 primes. Oh wait, what? Is this 10? No, that's 11 primes before you can conclude that it's a prime. Basically, it's very tedious, right? So if I'm doing this during competition, I'll just believe that it is a prime and then I'll just put down 2026 as my answer. Because if it's not a prime, then the remainder will just be 0, right? So probably there's nothing to do then. And then question 23 shocks me again. Integration inside the SMO senior. But this integration is not difficult. The only thing you need to know about integration for this question is that integration is the area under the graph. So how to plot fractional part of x from 0 to 2026? Well, from 0 to 1, the fractional part just goes like this. And then at 1, it drops back down to 0. Yeah, so the y coordinate is actually never higher than 1, right? Because it's a fractional part. So it drops down to 1, continues the process, it drops down to 2, and then it continues the process, so on. So if you notice, through this process, what's the area underneath the graph? This is half times 1 times 1. This is half times 1 times 1. This is half times 1 times 1, and so on. The answer is half times of 2026, 1013. And then question 24 is another shocking question, because this question I will spend a lot of time on, and then in the end, turns out the question is wrong because there are infinitely many of them. So, for example, there are many. If you notice that if q is odd, and then p is equals to q squared minus 2q, it works. So you can just check it yourself. Okay, never mind. I'll check it for you. I'll check it for you. So obviously, the first one is integer, right? Because of the fact that the numerator is a multiple of q squared minus 2q already. Let me just check the second one. The second one here will be looking like um, q squared minus 2q in the bottom. Then you have q squared minus 2q plus q. So this is a q squared minus q on top, right? And then there's a 2q below. But then what that is just q minus 1 over 2. So as long as q is odd, this will be integer. So there's infinitely many. Okay, now, so actually out of all these questions, question 5, which is scary, again, actually looks the most normal. Because this question is a question that quite commonly appears in SMO. At least the idea is quite common. It looks scary, but all we need to do is to substitute x equals 0. Okay, not exactly true. I kind of lied a little bit. You need to substitute x equals 0 and other values as well. If you let x equals to 0, you can get g0 squared. Then what's this guy? Where x is 0 is minus 3 over minus 1 is 3, g3 cubed. Last one is 3 over 2. g3 over 2 to the power 5, that's equals to 1. But then now, surprisingly, to find the value of g3, you just substitute x equals to 3. You have g3 squared. Then what happens when x equals 3 here? You have 3 over 2, right? g3 over 2 cubed. Last one, g0 to the power 5, that's equals to 7. And then x equals to 3 over 2, g3 over 2 squared. Then you have g0 cube. And then lastly, you have g. If you're going to put x equals to 3 over 2, you can check. Check and put it in. That is g3. So g3 to the power 5 here. That's equals to 4. Okay. So now, how to find g0? So obviously, thing to do is probably to multiply all of them together, right? Honestly, probably, right? So probably you want to multiply them together. So that equals to 28. That's equals to g0, g3, g of g of 3 over 2 to the power of 10. Okay, so yeah, okay. So we can get something. But after you get this thing, the question becomes how to remove the g3 and g of 3 over 2, right? So I'm thinking of a way to remove that. Maybe if you notice, here the g3 is 2, here this is cube. Here this is cube and this is 5. Maybe I can take maybe I can square this guy, right? So let me square the second expression actually. So if I square the second expression, I can get g3 4, g3 over 2 6, g0 10. That's 49. Then I can divide by the first expression, which is 1. So I can get uh, g0 8, g3 G3 over 2 is equals to 49 divided by 1 is just 49. Okay, so now if I take the 10th root of 28 and I can do the division here. So I take the 10th root of 28 and I do the division from these two, I can get G0 to the power of 7 is equals to 49 divided by the 10th root of 28. Ugh, what is this number? Anyway, you can figure out the primes here are just going to be 2 and 7, right? Which is a good thing. But what I need to furthermore do is I need to take this to the power of 1 over 7. So G0 is the 7th root of 49 over the 70th root of 28. Okay, maybe I was too quick to praise this question. Maybe I shouldn't have praised this question. So we're almost done, but let me just find a way to simplify this. So it's p to the power a over q to the power b. So here, how to do simplification? Um, that's 7 to the power of 2 over 7 divided by what? Okay, divided by 2 to the power of 1 over 35, 7 to the power of 1 over 70. Yeah, that looks right to me actually. So this is equals to 2 to the power of 1 over 35 at the bottom, 7 to the power of 2 over 7 minus 1 over 70, that's equals to 19 over 70. Hopefully. Okay, anyway, once you get these values here, you want to find 7 plus 2 plus 19 over 70 plus 1 over 35. Round up, that's equals to 10. Oh, this was a horrific SMO. Okay, I'll stay in case any of you have any questions. Hey, I don't know how we have the same amount of people watching this stream as just now, but I'm gonna stop it.